All right, let's do it. Good morning. I'm a little bit behind today. That's all right. We'll get caught up. All right, so quick review, right? What did we do last day? We are in 1.5 before we do 1.4, so that can be a little bit confusing, but you'll see why today. We talked about linear equations. We talked about briefly about quadratics, which we'll talk more about today. So we talked about linear equations, which have the form y equals mx plus b, or can be rearranged to some format where if you solve for y, your highest power of x is 1. Right, so you can rearrange something to look like this. That's a linear equation, and it just makes a straight line. Right, so we talked about that. And then we also talked about just solving linear equations, but also solving for a variable. Right, so different kind of techniques, right, to solve for a given variable. And we did a couple of examples, and that's kind of where our review ends. It was just on Tuesday, so we don't need that much of a review. But what I want to do is I want to jump right into an example of solving linear equations. Solving linear equations. Okay, so I'm going to go into our notes here, and I'm going to grab, I guess it's a PDF. Okay, I'm going to grab some of these problems. So like I said, this type of question, it's going to come up on the test for sure. It'll be on test 1. Whoops. Test number 1 and the final exam. Okay. So being able to tackle all of these, and remember, you have the solutions on Moodle, so make sure, kind of on your own time, just make sure that you have all of these under control, all these different versions, being able to solve for solve the equation. So what does that mean? All right, here we go. Let's see here. How about I want to do 27. Okay. And I'll leave 28. So I was tempted to do 28 because it's potentially the hardest one on here. But I'm going to leave it for you to try on your own because it's very similar to 27, except you'll have to factor this x squared minus 1 likely, right? So just kind of make a mental note of that for when you go ahead and do it on your own. But let's do 27 together. And it's going to be very similar to what we did at the end of the day last day. Okay. So we've got 3 over x plus 1 minus 1 over 2 is equal to, 1 over 3x plus 3. Now with practice, what you'll see is you'll be able to factor out a common 3 here. So then you have 3 times x plus 1. And I'm going to leave that for a little bit longer. But those are things that you're going to start to pick up on, right? Oh, okay, I can get an x plus 1, and here I'll have an x plus 1, right? And so things like that you'll start to notice. Now, we're not going to start there, okay? It's just things when I look at this that I see immediately, right? And so that's where you want to get to. I've got two fractions, I'm subtracting fractions, right? And so what I need is a common denominator. And so my common denominator, what I'm going to force it to be is just 2 times x plus 1, right? And so this term here, this first term is going to be multiplied by 2 over 2, right? And this second term is going to be multiplied by x plus 1 over x plus 1, right? And so I'm just forcing that common denominator. And then, so what's that going to look like? And then I'll be able to kind of get moving here. 3 over x plus 1. And I usually try to, so for me, when I'm showing you, I usually try to show the manipulations in a different color. So times 2 over 2 minus 1 over 2 times x plus 1. And I'll put those in brackets just to emphasize that it's multiplying all of that. Okay. I'm going to scoot this over because I want to stack my equal signs. Is 1 over 3x plus 3. Okay. So now, right, I can multiply two fractions. That's easy. I just smush them together, right, and multiply. So I get 3 times 2 is 6 over. And what I'm going to do is I'm going to keep this x plus 1 as is. Okay, so I'm not going to expand this 2 times x plus 1 inside. And that's just a matter of practice. If you were to expand it out, there's no harm in that. Because you could easily just factor out the 2 times x plus 1 anyways. But from experience, I know that it's better to just keep them separate. Okay? Minus, and then x plus 1 times 1 is just x plus 1 over 2 times x plus 1 is equal to 1 over 3. And here, what I'm going to do is I'm going to factor out that 3 that we were talking about. Right, so I'm going to extract that 3 times x plus 1. Okay. So what's slowly going to happen is this thing is going to simplify and eventually we'll be able to solve for x, right? And so that's what we mean by solving this linear equation. Okay, so I can combine this into one fraction. Okay. So I have 6 minus x plus 1. Careful with these brackets, right? Because we're subtracting, I'm going to have to expand that negative inside the brackets onto both terms, right? So I want to make sure I have brackets on here if I'm subtracting. And it's all over 2 times x plus 1 over 3 times x plus 1. Okay. So now what I'm going to do is I'm going to look at this and say, okay, well, I've got a fraction is set equal to a fraction. Okay. And so what I can do is I can cross multiply, right? And in fact, what I'm seeing is, okay, once I multiply this 2 times x plus 1 over to the right-hand side, right, which I can do because it's dividing on the left-hand side. So when I move it over, I have to multiply it. Then I'm going to see, that's when I see this x plus 1 canceling with this x plus 1. Okay, so this guy can move up top. What I'm also going to do is I'm going to expand the numerator here. So I get 6 minus x minus 1 is equal to 2 times x plus 1 over 3 times x plus 1. Okay. These two are going to cancel, right? I'm allowed to cancel things as long as it's a common multiple in both the numerator and the denominator. So I'm allowed to do that. So now I'm just left with 2 over 3, right, on the right-hand side. so that's nice. So what I can do to solve for x, right, now I just have one lonely little x here to deal with. So what I'm going to do is I'm going to shuffle everything over and solve for x. One thing that you can do, if you don't feel like dealing with a common denominator or dealing with fractions anymore, you can multiply this 3 over here, okay? I'm not going to do that because it's probably not obvious right away, but you can go back and try it by multiplying this 3 over, but it's multiplying everything, right? So just be careful. I'm going to keep it as a fraction for some more practice with the fractions. But like I said, that's also an option, moving that 3 over. So I get minus x minus 1 is 2 over 3 minus 6. Yeah. Then I can add 1, so negative x is 2 over 3 minus 6 plus 1. Slowly shuffle things over. If you wanted to just simplify up here, that's fine too. 6 minus 1 is 5, right? So plus 5 becomes minus 5. Nothing, it doesn't change anything. I've got this negative here that I'm going to shuffle inside. So what I'm going to do is I'm going to multiply or divide, it doesn't matter, by negative 1. It's easier for me to think about multiplying by negative 1 to get rid of this negative. So if you multiply this all by a negative, x becomes negative, and I'll make it a nice big bracket, 2 over 3 minus 5. I'll simplify that. Okay. You can use your calculator, but we have to have a common denominator again, right? So as soon as we're subtracting fractions here, 2 over 3 minus 5, we can rewrite as 5 times 3 over 3. So this becomes, and I'm going to keep that negative outside for a little bit longer, minus 5 times 3 over 3. So x is going to be 2 minus 15 over 3. Right, 5 times 3 is 15. I did that kind of quickly, right? But we're getting used to fractions, so we're going to be able to move a little bit faster here. 2 minus 15 puts me at negative 13. So I have x is negative 13, negative 13 over 3. Clean that up a bit, there. Which becomes x is 13 over 3 once I expand that negative inside. There, we solved the linear equation. And so if you have a look, okay, see, it was a long problem. If you have a look at all of these equations, you'll find that they only have one variable. And so when we say solve the equation, it just means solve for the variable, right? I'll make a note of that here. Because sometimes that's not obvious, right? When you're first getting into these types of problems, solving the equation, what does that even mean? Solve the equation means solve for the given variable, right? Here you're going to solve for x in 13. In 22, you're going to solve for y, but of course the mechanisms stay the same. The rest, and then in 29, you're going to solve for t, right? So just solve for whatever variable is in there, but there should only be one variable. Okay, good. So, like I said, definitely try 28 on your own because it's potentially the hardest one on here. But like I said too, it's very similar to 27, which is the one that we just did, right? So just try that on your own. Okie dokie. So here we solved linear equations, right? We solved for x, we solved for what value of x makes this true. In this case, what value of x makes this big thing here, 3 over x plus 1 minus 1/2 equal to 1 over 3x plus 3, right? We found that x must be 13 over 3. And that's not obvious, right? But we were able to solve for it and find that variable that makes that true, right? Or that value of x that makes that true. So now the other common equation that we're going to have to deal with is a quadratic equation. Okay, so let's talk about quadratics. Oops. That's the end of this example here. Quadratic equations. Quadratic equations, and I have a vague memory of mentioning quadratics earlier, but quadratic equations have the form ax squared plus bx plus c. Okay, so whenever you see something like this, yes, it's a polynomial, right? A polynomial because it has powers of x that are decreasing. And what's special about it is the highest power of x is 2. I'm having a deja vu. I must have said this already last day. The highest power of x is 2. Okay. And then we're allowing for these coefficients. These coefficients can be 1, so then you don't really have a coefficient, or at least not visibly. The only condition is that a cannot be 0. Okay, and the reason for that is if a were 0, 0 times x squared, well, then you don't have that ax squared term. You only have the bx plus c, which puts you back at a linear equation, right, where the highest power of x is 1, right? So you have to force a quadratic by saying, okay, well, x squared has to have a coefficient because that has to be my highest power of x. Okay? Otherwise, I have a linear equation. So quadratic equations, what I want to do is I want to show you how to pretty easily factor quadratic equations, because we talked about those special factoring formulas last day, and like I said, they don't really come easily to me, and I don't know, maybe I'm alone in that, but for me to recognize and pick out those special factors is really difficult. So for me, I like to have kind of ways that I can factor and it'll always work. And if I have a quadratic equation, we do have a way to do that. So to solve a quadratic is to solve for the values of x, and usually we have it as an equation. So when we solve quadratics, we have to solve for the x variable again, right? Same as we did with linear equations, but now we've got this x squared and an x that are kind of giving us grief. So let's see here. All nab. I guess I'll pull this in. We already said it, but it doesn't hurt to have it officially there. Okay, so notice that here we've got it set equal to 0. Okay, that's because if you have equal to anything, you can always move that value over and incorporate it with a c. Okay, but if we have this, and maybe there we go. So we have to have it equal to 0. But what that means is when we solve for this system of or this quadratic equation, then if we're forcing it to be equal to 0, what we're saying is we're solving where it crosses the x-axis, right, where y is 0. So solving quadratic equations means finding the values, and there's going to be 2, the values of x that make y equal to 0. In other words, where does this quadratic cross the x-axis? In other words, find where this quadratic crosses the x-axis. Okay. Now, a key thing about quadratics is the shape of a quadratic is this. The shape of a quadratic is like this. So you could have something like this. I'll do it in a different color, right? It's this parabola, and because the highest power of x is x squared, it's going to behave like x squared. And then this kind of changes stuff that happens in the middle, but overall the behavior is going to be a parabola. So the overall behavior is a parabola. Okay. In this case, here, in this kind of default case, y is 0 and x is 0. Okay, that's the only place. Most of the time, though, this parabola is going to move around a little bit. Okay, so we might have something like this. That could be a quadratic, right? So then what we're finding is these are where we cross the x-axis, right? And so when we solve the quadratic, okay, so solving the quadratic gives these points, often called the roots. Okay, so we can call those the roots. Sometimes they're called that. Okay, but here, so where these, where the parabola crosses the x-axis, those are your roots, right? And this parabola can be facing up, it can be facing down, and we're going to deal more with quadratics later in their graphs. But for now, right, it's just important to recognize that, okay, if I'm solving this, what I'm actually finding are the values of x where it crosses the x-axis, okay? There will be cases where there are no solutions. So there are quadratics with no solutions. Such as, right, if you consider a graph like this, if you think about a parabola that maybe looks like this, well, it'll never cross the x-axis because the lowest point is up here, right? And so it doesn't have any solutions, right? And that's fine, and I'll show you what that looks like, Okay. All right, so the formula for solving a quadratic, right? So the formula for finding these roots is the quadratic formula. Okay, so to solve quadratic equations, oh, I've got this little thingy that I forgot to put on my pens, and because I grip so hard, I try not to, but I don't know why I write incorrectly. But so to solve quadratic equations, we use the quadratic formula. Which is, of course, on your handout, and it's on the second page. Okay. I'll make it huge because this is going to be so important. Okay. The roots of the quadratic equation, which has the form ax squared plus bx plus c equals 0, are this big nasty. Oh, I don't know what's going on here. Okay. All right, sorry, I lost you guys for a second. Not sure what, there. Okay, so x is going to be negative b, where b is from the quadratic, plus minus the square root of b squared, so that same b, minus 4 times a, which is the first coefficient, times c, which is that constant. And then that's all over 2a. Okay. So, all right. You'll need to memorize this, right? I don't ask you to memorize a lot, but for you, memorizing just means having it on a piece of paper that's always available to you, right? So just make sure that you always have the quadratic equation ready to go. We will use it so much throughout the term, and even if you go into calculus, we'll use it again, especially if you have to factor a quadratic, right? So first step, learn to recognize quadratics. Okay. Oh, sorry, saw something in the chat here. Oh yeah, so this formula is pretty nasty. So we're gonna use it. Is this the one you mean, Wendy, this big nasty? Yeah. Yeah. We're going to use it a lot. So I'll do an example. But what we're doing, right, is we're solving for values of x. Because we have this plus minus situation, that's how we're going to end up with 2 points, right? And so notice that most of the time, if we have solutions, there should be 2 of them, right? If we're facing up, well, where we cross the x-axis, there should be 2 points, right? And so let us do an example of how to use this thing. Let's see here. There are a couple of things on here. Completing the square, I'm going to put that off until we need it in chapter 3. Okay, so just maybe make a mental note. And then we're not going to worry about the discriminant. So there are a couple of things here. I've got some practice problems on here, but let's see here. Let's grab some of these problems to be able to practice them. Okay, so let's see here. Let's start with 67. Okay, so we're asked to find all real solutions of the quadratic equation. So what we want to do is we want to find the x's that make this statement true, right? X squared minus 13x plus 42 equals 0. Notice that it has to be equal to 0, right? That's one of the conditions, right? Is that it has to be equal to 0. Must be set equal to 0. Otherwise, you're finding where it crosses the y value. Yeah, so let's try, so how about, let's do 67 and then good call, let's do 78 together as well, right? Where it's not set equal to 0, but we have to force it to be equal to 0. Good, I'll underline those to remind myself here. Whoop, whoop. Okay, so 67. So what we want to do is we've got x squared minus 13x plus 42 is equal to 0. So we want to solve, so find all real solutions to this quadratic equation. All right, so we've got A, right? So what I want to do is I'm going to match this equation to this equation, okay? So here, I'm gonna say, okay, well, A must be equal to 1, right? B, making sure you keep that negative, right? B must be negative 13. And C must be 42, right? Because these are the A, B, C's that we're gonna use in our quadratic formula. Okay. So you need to first identify your A, B, and C, your coefficients, and then we can plug them in. Okay. So what we're going to find is that, okay, the quadratic formula says that x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. Now, I know you're probably looking at this thing and going, I'll never memorize this. And then joke's on you, a month from now, it'll be memorized. So, because we use it so often. Okay, so here we go, right? Because we've identified A, B, and C, we just have to plug them in, right? Making sure you keep those negatives if there's negatives, because otherwise it'll mess things up. Okay, so in our case, x is negative b, which is negative 13. So I want to keep that negative here. Negative 13 plus minus the square root of b squared, which is negative 13 squared. Whenever you square a negative, you just get a positive value back, right? So, but you want to make sure that you show that it's the negative. Careful on your calculator, right? You might have to put brackets around the negative 13 before you square it. If it gives you a negative value, right? So here, let's go to our little calculator here. For example, if I do, let's see here, negative 13 squared, see how it gives me a negative number, right? That's not right. If I square a negative, it will give me a positive. It has to, right? And so what I have to do then is just make sure that I keep the negative 13 inside brackets and then square it. Okay? Just to make sure because you don't want your calculator doing something incorrectly, right? And it's doing it correctly, but it's keeping the negative on the outside. So you want to force it to be inside the square. Okay, so minus 4 times a, which in this case is 1, and c, which in this case is 42. Okay. All divided by 2 times 1. Okay. So let's see here. Negative times a negative becomes a positive. So I get x is 13 plus minus. And then what I'm going to do is I'm going to simplify under the square root here, making sure I follow BEDMAS, right? And so I just found that negative 13 squared is what, 169, I think? Yep, 169. So I'll jot that down. Minus, and then I have to multiply 4 times 1 times 42. Okay, so I need to find 4 times 42, right? So 4 times 42, oops, 4 times 42 is 168. Okay, good. All divided by 2 times 1, which is just 2. Okay, so always find this square first, and then multiply these terms together before you subtract, right? So you need to simplify both of these terms before you subtract them from each other. Okay? Now, what I need you to keep in mind here is if you get a negative number here, right? We can't take the square root of a negative, but if you get a negative number here, that's the situation where you have no solutions, right? Which we saw can happen, right? So if you end up with a negative number here, that's fine. You just have no solutions. Okay? And I'll make a note of that after we're done this problem, right? Because I didn't leave myself enough space over here to write it. Okay, so what I have is x is equal to 13 plus minus the square root of 1. Hey, all of a sudden it's nice to look at, right? 169 minus 168, and then divided by 2. The square root of 1 is just 1, right? You can try it on your calculator, but it's just 1. So x is 13 plus minus 1 over 2. Now what's important is this becomes 2 equations, right? 13 plus 1 over 2 and 13 minus 1 over 2. Okay. So x becomes 13 plus 1 over 2, and x is 13 minus 1 over 2, right? So just make sure that you do both of them individually. Okay, so what you have, 13 plus 1 over 2, x is 14 over 2, and if you wanted to skip straight to 7, that's fine. But I just want to show every step. So 13 minus 1 over 2 is 12 over 2. Okay. So of course, x equals 7 and x equals 6. Okay. So now we've solved this quadratic, okay, and it'll work, and by work, I mean it'll set everything equal to 0, remember, right? So the goal was to find what values of x make this equal to 0. X equals 7 makes it 0, awesome. And x equals 6 makes it 0. Okay. So I always like to give you ways to check your work, right? And so you can check your work using Desmos if you graph this thing, right? And so what I want you to do is let's graph x squared minus 13x plus 42 and just ignore the 0 for now. So it has to be equal to 0 because this is our y value, right? And so we're forcing it to be y equals 0, okay? Which is our x-axis. So if we graph it in Desmos, I'll be able to show you a little bit better. So x squared minus 13x plus 42, that's what I want to graph here. Oops. X squared minus 13x plus 42. Okay. So like we said, this thing looks like a parabola. And when this thing is equal to 0, right, that's when we're on, oh, I don't have a pointer here, but that's when we're on the x-axis, right? Because when y is equal to 0, right, here y is equal to 2, for example, right? And so we're forcing y to be equal to 0 to find where these values make the y equals 0. The y will always be 0 because we force it to be 0 in order to use the quadratic formula. Okay. So what we found, right, is that it crosses the x. Let me just kind of do this. Oh, really? We found that it crosses the x-axis, right, at x equals 6, and then we forced it to be y equals 0, right, because that's why we have that equals 0 value. And then same thing, it crosses the x-axis at 7, 0, so when x is 0, or when x is 7, y is 0. Okay. So I'm going to graph this in our notes just quickly. It kind of looks like this. 6, 0, 7, 0. Yeah, so the equals 0, here, I'll just make a note here. This is your y-axis and this is your x-axis. Maybe I'll use this color here. On the x-axis, y is equal to 0, right? And so here, y is equal to 0. Y is equal to 0 because we've got this x-y ordered pair, okay, which I can't remember. I don't think we've talked about quite yet, right? But when we talk about points on a graph, we usually denote them by x comma y, right? So when x is 6, y is 0 because we forced it to be 0, because we want to find where does it cross the x-axis. The x-axis is the y equals 0, right? And so this is why it's important. This is why it needs to equal 0, right? Because that's what we're forcing. Nice. This is a really, really tricky thing to kind of get, okay? But once you do, it's going to be really, really useful, okay? Because what we're going to do is we're going to be able to use this in order to factor, okay? So we can use the roots to factor quadratic equations. And this is why I introduced this first, so that we're not kind of scrambling and trying to factor this nasty parabola and quadratic, but instead we'll just always use this method. Okay, so was there anything else I wanted to say here? Oh yeah, so x equals 6 and x equals 7, those are our roots, right? And so those are the solutions to the quadratic. Okay. We use the roots of a quadratic equation to factor a quadratic. Okay, so how do we do that? Well, so from here, right, we found the solutions to be x equals 6 and x equals 7. Okay, so what we're saying is in x squared minus 13x plus 42 equals 0, we found the roots to be x equals 6 and x equals 7. Just listing them in increasing order. Okay, doesn't matter. Okay, so what this means is that when x equals 6, this thing is 0, and let's try it, right? 6 squared, right? So try 6 squared minus 13 times 6 plus 42, right? So let's try 6 squared is 36 minus 6 squared, and 13 times 6 is 78. Okay, let's write that down. Minus 78 plus 42. 36 minus 78 plus 42, here we go. 36 minus 78 plus 42 is in fact 0, right? Which is what we forced. But you always want to make sure, so you can check your work multiple ways. You can graph it, you can plug them in, make sure that they work, okay? Got options. And so equals 0, which is what we want, right? Because then it makes the equation true. And you can try it with the 7 as well, but it's going to work. Okay? It's going to make it equal to 0. So if you found that x equals 6 and x equals 7 make this thing 0, right? What you can do is you can rewrite this as a factor. So to factor x squared minus 13x plus 42 equal to 0, or later on, we're not even going to need that 0. We just imagine that equal to 0, right? So then as soon as we see something of this form, right, we'll be able to factor it using the quadratic equation, quadratic formula. So to factor this thing, okay, what we need to remember is that x equals 6 makes it 0 and x equals 7 equals 0. You remember that x equals 6 and x equals 7 make the equation equal to 0. Okay. So what I do is I'm going to have x times, or x plus minus something times x plus minus something. Okay, so what this is going to look like is x squared minus 13x plus 42 is going to become x times And here, I'm just leaving room for my roots, okay? So just to emphasize here, if x equals 6 makes it 0, then if I have x minus 6, so you always do kind of the opposite of the roots, right? Because you still want to preserve the fact that x equals 6 makes it 0, right? So x minus 6 and x minus 7. So when I put in x equals 6 in here, 6 minus 6 makes 0, right? And 7 minus 7 makes it 0, right? So either way, I'm going to get 0 if I plug in these roots. Okay. So notice here, notice that x equals 6 makes x minus 6 equal to 0, right? 6 minus 6 is still 0. 0 times anything makes 0, right? And so we're using that fact to factor this thing out, right? 0, so if x is 6, I get 0 times -1, that's 0. If x is 7, then I get 1 times 0, which is 0, right? So regardless, this is going to help us factor, right? And so we use the roots in order to factor. Okay. So what I want to do is just check to make sure that this thing expands to what we wanted, right? For me, looking at this, and usually in high school, and I don't know, usually what we teach is, okay, so it has to add to -13 and multiply to 42. What's that number? I always had a hard time wrapping my head around that. So for me to have this this safe way to factor it always has been really useful. So that's why I'm showing it to you. Okay, and so let's see here. So when I expand this out, right? Expand x minus 6 times x minus 7. Which is going to be x times x, which is x squared, x times -7 minus 7x, -6 times x minus 6x, and then -6 times -7 plus 42. So I get x squared minus 13x plus 42. Whee! So I get back to the same thing. All right. Okay, so do you mean here, Grand Prix? Probably. So it's a multi-step process, right? Okay, yeah, good. So what we do is if you have to factor this thing, right? The easiest way, it's a little bit longer, but the easiest way to do it, I find, is to first find the roots of this thing. So you use the quadratic formula, which we did up above here. Whoa, here. And we found these roots. Whoa, slow down. Okay. So we find these roots. Then we use these roots, okay? So now I take those roots, x equals, I don't know why it's lagging so much. It was lagging yesterday too. I don't know why. So x equals 6 and x equals 7 are my roots. Okay? So what I do is I take those and I say, okay, well, if x equals 6, then I still have to get to 0, right? So what I do is I take x minus 6, because then when I plug in 6 for x, I get 6 minus 6, which makes 0, right? And then same thing here with my 7. So you basically just take the the opposite version of, so here you have positive 7, so then you'd have to subtract 7. Here you have positive 6, so we'd have to subtract 6. Okay. So what we have, right, is now we're able to factor this out, right? So we can change this. Usually we'll have to factor this quadratic. And so now I can rewrite it like this, x minus 6 times x minus 7. And then what you can do, just to make sure that you get back from here to here, right? Now, just to make sure, double check your work, right? X minus 6 times x minus 7 is the same as x squared minus 13x plus 42. Yeah. It's gonna make a little bit more sense, maybe. So we're gonna use this quadratic formula to factor quadratics. Okay. Let's do another one. Awesome. So let's do another one. We'll do lots more, but or we'll use this property a lot. So we'll end up using it a lot. But make sure you work through some. Oh, I think I have the problems here. Okay. So make sure that you work through these, right? You've got the solutions on Moodle, so pick one, work through it, make sure that you find the real solutions, and then here, it doesn't say to factor, but construct those factors, right? So factor this thing and expand it out to make sure that it works out to be the same. Now, I wish I had made a note of which ones give me some different solutions. Let's do 78 together. Okay. Because that is one that's not set equal to 0. W squared is equal to 3 times W minus 1. So even when you see this, right, as soon as you see your highest power is 2, you can make this into a quadratic, right? So if you have to find the real solutions, or if you have to factor it, then you can use the quadratic formula. Okay, so let's do 78, and I'm gonna have to copy so I can bring it down here. I'll put it on a fresh page here. Okay, wonder if I can, no, erase, I can't. Find all real solutions. Oh, I know what I was gonna make a note of. And maybe that's, I'll have room here. Note, right? We said some quadratics will not have solutions, right? What that's gonna look like is if you have a negative number in the square root. Remember, we can't take the square root of a negative number. Okay. So if we find that x is equal to negative b plus minus the square root of b squared minus 4ac over 2a, okay, tries to take the square root of a negative number here. So if b squared minus 4ac becomes negative, right, we have no solutions. So if we find that x equals negative b plus minus the square root of b squared minus 4ac over 2a requires the square root of a negative, we have no solutions. Oh, clean that up a little bit. There, no solutions. Okay, and graphically, what does that look like? Well, if we have something, right, in a graph, and our parabola maybe looks like, let's do it down here this time, right? It's pointing down, then it'll never cross the x-axis, right? So it could be pointing up above the x-axis, or it can be pointing down below the x-axis, right? Either way, you're never going to cross this x-axis. So there will be situations where you have no solutions, right? And therefore, you can't factor that thing. Right? If you have to factor it, it'll have solutions. So don't worry about that. Okay. But that's just the side note, right? If you end up having to take the square root of a negative, there are no solutions, and you can just stop there because there's nothing else you can do. So here, I'm going to expand this question and say, find all real solutions. And hopefully there are some. And use them to factor the quadratic. So the first thing we need to train our eye for is saying, oh yeah, I can rearrange this to make a quadratic equation. Okay, so first thing I'm going to do is I'm going to say w squared is equal to 3 times w minus 1. And maybe I'll put this in the center of my page here. Okay, so what I'm going to do here is just remember, so to find the real solutions of a quadratic, I have to set it equal to 0, right? I have to force it to be 0. So what I'm going to do is I'm going to expand this 3 out, and then I'm going to move everything over to the left-hand side, making 0 on the right-hand side. So I get w squared is 3w minus 3. So moving everything over, I get w squared minus 3w plus 3 is equal to 0. Right, just kind of move everything over. And once you've subtracted 3w and you've added 3, you're left with 0 on the right-hand side. Must have 0 on the right-hand side. Are you guys okay with that? I'll use LHS and RHS just because it's the right-hand side and the left-hand side, right? Or on one of the sides, it doesn't actually matter, okay? So you have to have 0 on one of the sides, okay? But now you have this quadratic equal to 0. Okay? So now you'll be able to use the quadratic formula. So if we just kind of w squared minus 3w plus 3 is equal to 0. Just writing it out bigger so that I can underline things here. So a must be equal to 1, right? A is always the coefficient on the square. And then b is equal to negative 3, and c is equal to positive 3. Okay. So to find the real solutions, our variable here is called w. That doesn't matter. It's still going to be essentially our x. Okay, so whatever the variable name is, call it w, is plus minus, or sorry, negative b, I almost forgot the first part, negative b plus minus the square root of b squared minus 4ac over 2a. So to find these solutions right now, because I have rearrange this and set it equal to 0. Now I'm able to use the quadratic formula, which means I have to identify A, B, and C, right? Once I've done that, I plug those values in here, just being careful, preserving negatives and that kind of fun stuff. So W is going to be -3 plus minus the square root of -3 squared minus 4 times 1 times 3. And then that's all over 2 times 1. Okay. So again, be really careful. So simplify this -3 squared, which is 9, and then minus 4 times 3. Uh-oh, right? It's okay. It's okay. Why did I say uh-oh? 9 minus 12. Square root of a negative, it's not going to work. That's okay. We're going to keep going here. So we've got 3 plus minus the square root of 9 minus 12. Okay, all divided by 2. Since I can't take the square root of 9 minus 12, 9 minus 12, I don't know, it's a negative. Oops. -3. Brutal. So since I can't take the square root of -3, right, we find we have no solutions. So let's just confirm that, right? We have no real solutions. If you keep going in math, there are imaginary numbers, and those evolve when you take the square root of a negative number. Now, we're not going to go down that route, but it does exist. It's a thing. So there are no real solutions. Maybe I should add that. No real solutions. Okay. Real being the set of real numbers. Okay. Let's graph this just to make sure that we're on the right track here. Okay, so what I want you to do is we can even, let's graph, w squared minus 3w plus 3. When I graph this, I'm going to replace the w's with x's just because I don't have a w button on my Desmos graphing calculator, right? So I'm going to do x squared minus 3x plus 3. And it doesn't matter what variable name you have, right, when you're graphing. So x squared minus 3x plus 3. So I've got x squared minus 3x plus 3. Sure enough, right? So this confirms that what I found is legit, right? It confirms that this thing is never going to cross the x-axis, and so we'll never have a solution, right? So this one, we're not going to have any luck. We won't be able to factor it using the quadratic formula, but for us, I wouldn't get you to factor something like that anyways. Okay, so our graph confirms that there are no solutions. Graphing x squared minus 3x plus 3 in Desmos confirms there are no roots, right? Which means no real solutions. because I think it ended up looking something like that. Something like that. Okay. Good. Let's do another one. I forgot to give you guys a break, didn't I? How about, let's do another example and then, no, now I'm torn. We'll do a quick 3-minute break. How about that? Till 9:15. Quick break today. Sorry about that. All right, so let's see here. I will want to do another example. Let's do number 80 together as well. Now I'm just hoping. What I'm gonna do beforehand, just to make sure that it's gonna do what I want it to do. How about, I'll just graph this quickly, 25x squared plus 70x plus 49. 25x squared plus 70x plus 49. Oh. Okay, yep, let's do that one. It's not exactly what I wanted to show, but that's okay. So, I'll grab 80 here, but wow. There. So, find all real solutions and use them. I made one word. And use them to factor the quadratic. Okay. So you've got 25x squared plus 70x plus 49 is equal to 0, right? The first thing you want to do is make sure that it's set equal to 0. Okay. Just for let's just say that instead of plus 49, it was plus 40 and then equals -9, right? So just for kind of illustrative purposes, let's say you had that, right? The first thing you would have to do is you would have to add this 9 over here, right, to set it equal to 0. So even if it's not equal to 0, you'd have to force it to be equal to 0. Okay. So, but in this case, we have 49 equal to 0, so we're good. But that's how you would deal with it. You would just incorporate it, move it into the constant. Okay. All right, so let's highlight first. So make sure, okay, I recognize that this is a quadratic, great. Here, my A is actually going to be 25 for once. My B is 70. And my C is 49. So if I have to find the real solutions, I'm going to use the quadratic formula. So x is negative b plus minus the square root of b squared minus 4ac over 2a. Okay. So I get x is negative 70 plus minus 70 squared minus 4 times 25 times 49. All over 2 times 25. Okay, so we have negative 70, so x is going to be negative 70 plus minus, and I want you to simplify 70 squared and 4 times 25 times 49 individually first, right? And so instead of switching between the screens, I'm just going to do it here on the side. So 70 squared is 4,900, and hopefully you have a calculator on your end here. 4 times 25 times 49, dun dun dun. Okay, over 50. 2 times 25 is 50, of course. Now here, what I get is 49 minus 49, that's 0, of course, okay? And so what I have is I have the square root of 0, which is fine. I'm allowed to take the square root of 0. So x is negative 70 plus minus 0 over 50. Okay. All this means is that, well, negative 70 plus 0 or minus 0, it doesn't matter. But what I have is I have this factor twice, okay? Because I still kind of cross twice. Now, let's see here. X is negative 70 over 50. 70 over 50, if you have a fancy calculator, just simplifies to 7 over 5, or maybe just a fancy brain. So x is negative 7 over 5. Okay. So our root, and this is what we found, right? Negative 7 divided by 5 is approximately negative 1.4. And that's what we found, right? But this root happens twice, right? So it kind of goes down and then it bounces off. Okay. So this is a special case, right? This root happens twice, right? Because you're still going to have two roots. And so what this thing looks like, and it's not that common to have this situation, so that's why I'm not going to spend too much time on it, but I want to show you what it looks like right here at negative 1.4. I have this. Okay. So it comes down and it just touches and then it bounces off. So I typically want the exact answer, right? But Desmos, if you're checking your work, gives you the decimal approximation. And if WebAssign wants the decimal, it'll tell you how many decimal places. So see if it asks for the number of decimal places. In that case, go for it. Otherwise, stick to the exact answer. That'll always get you to the right spot. Okay. Now, the tricky thing is, how do I use this to factor, right? How do I use this? So remember, our goal was to use the roots to factor the equation, okay? So what I want to do is I want to show you, okay, so if I did the same thing, x plus 7 over 5, right? So to use the root, still two roots, it goes down and bounces off. So to use the roots, but there's just the one number, to factor, we need to manipulate the fraction a little bit. We need to manipulate the fraction. So whenever you find a fraction, that is the root. Okay, so don't get confused. That is the root. But when we're trying to factor, right? So what we're saying is that, what was the equation we started with? 25x squared plus 70x plus 49 is equal to, and just using that same setup as before, okay, I can still use that root, negative 7 over 5, right, in order to force a 0. So now I have to add 7 over 5, but because I only have the 1, it happens twice. Okay, so I want to make sure that, okay, x equals negative 7 over 5 should still give me 0, right? I can still break this up into x plus minus something times x plus minus something, right? And so, but it gets a little bit weird, right? This is x plus 7 over 5 squared, right? So first thing we can do is we can make it squared, right? So here, this becomes x plus 7 over 5 squared. Okay. So what I want to do is I want to take x plus 7 over 5, and I'll make these brackets big. Now what you would find if we tried to expand this, right, so go from here back to here, that's not quite true, right? We would have to, we would end up with some nasty fractions, right? And so here, what we're going to find is that this is not equal to that quite yet, okay? So what we have to do is, and you can try it, right? But I am running short on time. So try it, expand it out. X times x is x squared. X times 7 over 5 is 7 over 5x plus 7 over 5x. Okay, so that's going to be 14 over 5 x. And then 7 over 5 times 7 over 5 does not make 49, right? So that's my pickle. So what I have to do is I need to multiply this 5 over here, right? And so really what I'm doing is I'm saying, okay, well, I'm going to multiply this 5x, right? 5x should be equal to negative 7. So then what I have is 5x plus 7, and this should work. So what I get is 25x squared plus 70x plus 49. And what I do when I'm not sure, so I need to make sure that it's equal to each other, but I'm not sure at this stage, right? I put a little question mark over the equal sign. And so what I do is I say, okay, well, I'm going to bring this over here, 5x, okay? And really what I'm doing, so you could do it at this stage, or if you prefer, you could have brought this 5x over here. Okay? because what we're saying is that, okay, this thing's going to be 0 when 5x is equal to -7. So then what we have is 5x plus 7, right? When 5x is equal to -7, -7 plus 7, that makes 0, right? It's a bit of a stretch, but for me, in my mind, all I do is kind of bring this over. But if you wanted to convince yourself that that works, then you can bring it over onto the x in x equals 7 or -7/5. So what we get is we get 5x plus 7, and then because it happens twice, right, that's when it's squared. So what I want to do now is I want to expand this to make sure that it factors out and expands to what I started with. So this becomes 5x plus 7 times 5x plus 7. I'm just going to take my time and expand this out. 5 times 5 is 25. Hey, we're on off to a good start here, right? 5x times 5x is 25x squared. 5x times 7 is plus 35x. And then 7 times 5x is plus 35x. Hey, looking good. Plus 7 times 7 is 49. So that makes 25x squared plus 70x plus 49. So when we end up with fractions as our root, that's our root, that's fine, okay? But when we use that, we have to manipulate it a little bit in order to use it to factor. So when our roots are fractions, we need to manipulate them a little bit to use them to factor. Now, there's a lot of kind of confusing terminology here, right? Fractions, factoring, but just keep them all separate, right? So that's part of what we're learning here is, okay, so when our roots are fractions, those are our roots, right? -1.4 is our root, right? Thinking about the fraction as a decimal is a little bit easier. So when our roots are fractions, we have to get them out of a fraction before we can use them to factor, right? Whereas earlier, when we had our roots as 6 and 7, right, that was easier because then we can just use those roots, right? But as soon as we're dealing with fractions, we have to manipulate them a little bit. Okay. So maybe I'll make a note up here, right? So if you have x equals -7/5, then 5x equals -7. Use this to factor. So I just went back there and made a little note here of what I was saying because I realized I didn't write it down. Okay. But just keep them separate because this is still our root, right? This is where it crosses the x-axis, bounces off, right? But this was kind of a weird example. It's pretty rare that we have something that's just touching the x-axis and then bouncing off, but it's good to have seen it. So, all right. Good. Let's do, as a note, in section 1.5, we talk about completing the square. I'm going to leave that until section, I want to say 3.1, I think. I'm going to leave it until we need it. Okay, so just as a note, section 1.5 also covers completing the square Okay. But we will leave that until we need it in 3.1. All right, so I will refer back to this section, so maybe keep it handy, but not for a while yet. Okay, so we will see more quadratics as we move into section 1.4. So what I want to do is just start 1.4 so we can kind of get into it a little bit. Okay. Section 1.4 is called what? Oh, rational expressions. Okay. Yeah, so the homework for 1.5, you'll definitely have to use the quadratic to find the real solutions. So you'll get practice there as well. Yeah. Does that? Okay. So, good. So rational expressions are things like, now let's see here, where's 1.4? 1.1, there. What? So a rational expression is anything that looks like these first three problems. So anything where you have a polynomial divided by a polynomial. Now, a lot of the time, that polynomial will be a quadratic, right? And so that's why I go into and introduce and show you how to deal with quadratics first, because otherwise we're kind of floundering and oh, we don't really have a method to deal with these things. And then we introduce it later. So that doesn't really make sense to me. So a rational expression is just a fraction of polynomials. Okay. A rational expression is a fraction of polynomials. Right? So polynomials are just x to the power of something plus and then decreasing powers of x, but no square roots or anything like that. Okay? So let's see here. Let me just do a scribble on here so it moves to the top. Okay. When we're talking about fractions, okay, we need to talk about the domain of an algebraic expression. So an algebraic expression is just anything, addition, subtraction, division, multiplication. Okay, so as soon as we are dealing with, so when we deal with fractions, we need to figure out what the domain is. Now the domain are all the valid inputs of x, right? So we need to find the domain, which is all possible inputs of x, right? So it's all possible values of x. And I'll highlight this because that's going to be important, right? So some of the things that we need to keep in mind for finding the domain are we can't divide by 0. We've already established that, right? So to find the domain, we need to remember number one, we can't divide by 0, right? So any value of x or any input that makes us divide by 0, we extract from the domain. So we can't divide by 0. And we can't take the even root of a negative number. We can't take the even root. So the square root is the second root, right? So that's even. So we can't take the even root of a negative number. Those are the only two things that we need to remember for now. When we get into logs, just as a heads up, we're going to have to add another condition there, but we'll just add it when we get there. Okay, so for now, it's just two things. We can't divide by 0, and I can't take the square root of a negative number. Okay, so it's got this little summary blip here. Okay. So if you have something like 1 over x, and of course this is simplified, if you're talking about, a quadratic over a quadratic, you would need to extract the roots of the denominator, right, which is what we were just doing, from the domain, right? So here it's the set of x's such that x is not equal to 0. Remember, I'm getting you to read the set builder notation, but if you wanted to just write x not equal to 0, that's fine too. Here, we're saying, okay, I can't take the square root of a negative number, so x has to be greater than or equal to 0. I can take the square root of 0. Whereas here, if the root is in the denominator, then I need to combine the two, right? I can't take the square root of a negative, but I also can't divide by 0, so I need to extract the x equals 0 option, right? Because then I would be dividing. So here we're doing a combination of the first two. Okay, so let's do some practice finding the domain. Put it here. So we'll start with 7. Okay, because it's good to see something like 7. So 4x squared minus 10x plus 3. So we have to find the domain of the expression. Now, one thing, what's nice about here is, so you check, is there any division, right? I can't divide by 0, so I look out for division. There's no division. I can't take the even root of a negative number, so I'm looking out for square roots or even roots, right? 4th root, 6th root, whatever. There's none of that. And so as far as I can tell, there are no restrictions on x, and there aren't any, right? So when we're talking about plain old polynomials like this, the domain is a set of real numbers. So the domain here is, usually we end up using, oops, should be round brackets. Usually we end up using interval notation, right? From negative infinity to positive infinity. Or if you want to say the set of real numbers, right? Or the set of real numbers, those are equivalent. Okay? Remember to put round brackets around infinity. Infinity is not a number. And so we can only have round brackets here. Right? So here my kind of checklist is no division and no roots. So there are no restrictions, therefore no restrictions on the domain. Okay. Whereas if we go to 9, okay, let's have a look at 9 here. next class. If I have x squared minus 1 over x minus 3, here I need to pay attention, right? I'm dividing by x minus 3. So because I've only got division here, right, I don't have to deal with any roots, but what I need to make sure is that x minus 3 can't be 0, right? So here we're saying x minus 3 cannot be 0. I can manipulate this as if it's an equal sign. So that means x cannot be equal to 3, right? And you can try it. Just plug in 3. 3 minus 3 is 0, which is the one that I'm not allowed, right? So then the domain, if we continue to write it in interval notation like this, right? The domain up top here, I'm allowed to put in any value because it's polynomial, and so there's no division, no roots in the numerator. And so, so there I'm allowing anything. The only restriction is that x cannot be 3. So in interval notation, how we write this is we start here at negative infinity, and then we go to 3, but not including 3. So we do a round bracket. And then we're going to do a U to connect these, right? The union. And then we pick right back up at 3, but not including 3. And then we're able to go to infinity. So this is how we're going to start to build up our domains with interval notation. You just connect the different regions with a U. Okay, so from negative infinity up to 3, not including 3. And then we pick right back up at 3, right? Because x cannot be 3, but that's the only restriction. Okay, so I know that's confusing, but have a look. I'm out of time-ish. So definitely go through and try to work through the rest of these domain problems on your own. Right, you've got the solution, so you can always check back. And then we'll work through some of these. I want to do 13 together, and I also want to do 14 together at the beginning of next day. And I'll need you to remind me, or I'll do my own reminder here. I'm gonna just move this up one line. Do 13 and 14 next day. Okay. So try that. It's okay if it feels confusing, right? But what you need to remember is, okay, I can't divide by 0. So as soon as you see division, you have to say, okay, I need to pull out any x's that make me divide by 0, right? And I can't take the even root of a negative number. So as soon as I look through here and I see a square root, a square root, a square root, I'm going to need to deal with that, right? I can only take even roots of positive or zeros. Okay. So go through, try the rest of these, especially 13 and 14, and that's where we'll start as a review next day. How about? All right. Any questions? So I'll stop the recording here. If no